Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge first question. So let us first read this question, constraint, and finally intuition and coding and type complexity for the same. So let us first read this question. So here, count pair of similar strings. We are given the zero index string array words. Two strings are similar if they consist of same characters. So that's the thing. And now, for example, A, B, C, A, and C, B, A are similar since both consist of characters A, B, C. Then, however, A, B, A, C, B, A, and B, C, F, D are not similar because they do not consist of same character. Here you can see that F is here, F and D are here, but here F and D is not there, right? So that's why they are not similar characters. Oh. Return the number of pairs ij such that with the increasing order towards the word length, the the two words word I and J are similar. So basically, in this input which is being given to us, we are required to figure out that this particular first word makes pair with which other words, and then this particular word makes pair with which other word. Is only just one pair consist means the other way around. ABA, and then this ABA matches with out of all these words with or which all other word that we need to figure out. The thing is that we are means this ABA shouldn't match with itself. That shouldn't be the case. But ABA should match with any of these words. That should be the thing. Means any of them, and then comes the part for this particular. So this particular can match with any of these words, or even this could be also one of those words. But this would have already been matched at the starting only, right? When we were checking for this. So here in this we can clearly see that they have mentioned this and this match, right? So what they are, the first thing is that the character which are there, those should be similar. And similar simply means that A, then B. Even if A are repeated in any of them, that doesn't matter. But they should be similar. But if here comes D, then here if it is not D, say it is E, then surely that would be a match. So here the thing would be about checking for repetitive characters and even about dissimilar characters, and even the thing is that there all the pairs which could be matched should be matched, and no repetitive matching shouldn't be to be there. That is also one of the thing here. Repetitive matching means with the word matching with itself. Here ABA, that is AB, and then AB. These are matched. Then third and fourth, which is given to us is. So here BAC, and then other one has ABC. So again, it is a match. So like this, we are required to figure out. Now comes the part for the constraint. So we can clearly see that constraint are pretty much low. So easily n square solution would work here. So that's why we can directly go ahead with the brute force solution as well. Now let us go ahead with the implementation part for the same. So here, see, the thing is like, first thing is that there are repetitive things, right? So because of this repetitive, what we can do is we can clearly use unordered map set, anything like that, which could directly remove the duplication. Just for easing out our work, we are using this unordered set. Now, second thing which is there, we are also required to keep a check that our first word which is there, or whatever word which we have already checked, it doesn't map to itself. Means it doesn't maps to itself. That also we are required to check. Then third thing is that if at any point we are able to figure out that there is some dissimilarity, then at that moment only we are required to make that count equal to 0. Means count for that particular word as equal to 0. Means it is not a match. So these points we are required to keep in mind while implementing this particular question. Now I'll show you that how to implement this question. So here what I'm doing is, so this is the loop for traversing my words. Here I will be starting for my first word, means for the first word from wherever we need to start. So that is from here. Then here the repetitive characters for this particular word would be eradicated. Means basically repetitive eradication. That would be the thing because of this unordered set. And it will initialize it time and again so that for every new word, a new set is being used. So that's the thing. And now here I'm filling all the words in my set. Basically, uh, insertion of the first word for which we will be comparing. So that's the thing which I'm doing here. So this is for the second word, means because it is starting after I plus 1. So this is for the second word. And here again, now we are inserting our second word here. So that's what we are doing here. Now here comes the part, means our main part. Earlier we have just inserted where duplicate eradication was there. Now here what we are doing, from our first set we are checking, and here first we are checking that if size of either of them is not equal, then we are breaking out from that. And if we figure out that that particular I, means that particular character, if that is not present in P, then in that criteria we will be making our pre-count equal to 0 and just breaking out of this particular for loop. That is the thing. And when we break out from that for loop, so our pre-count was earlier 0. So that's why in this pre-count plus equals to pre-count, 0 will be added. Else in the case, if there is a match, then we will be making pre-count equals to 1. And every time there is a match, so pre-count will be equal to 1. And then we will be, when we come out from this particular for loop, then this count will become uh, equal to 1. Means basically adding up 1 to the same. Because there would be value for previous counts as well, means previous pairs as well, right? So that's it. And then we are again making pre-count equal to 0, but we are not required to make it again 0 because here we are already making it 0. So if we not make it 0 here, then also it will work fine. So, okay, but here we can directly make it as equal to 0, and then at the end we will be returning count. So this was about the implementation part. Now comes the part for the time complexity and space complexity. So space complexity is clearly order of n because we are using that unordered math. Sorry, set. So order of n. Time complexity here n and here also n, right? So n square into L. L is for the length of the longest word which would be there. So n square into L is the time complexity including the, this checking is taking this order of one time. So basically the time complexity is n square into L. So this is our time complexity, and the space complexity another set which we are using. So because of that. So and this time complexity completely favors the constraint word length 100 and each word length also 100. So both of them are n only. So basically, it is n cube solution. If we eradicate, if in the worst case scenario L also becomes equals to n, then in that scenario. Yeah, this was all for this particular question. Now, one more information thing that if you are already solving this bi-weekly and weekly content, then you can also try out the 𝐑𝐞𝐞 School Coding Challenge, about which you can figure out about the all details in the link which is there present in the description below. And if you are top performer in that particular contest, then surely you will be getting some exciting prizes, about which also you can figure out in that link only. So yeah, this was all for today. Thank you.